So for today's notes, we are proving special parallelograms on a coordinate plane. And our essential question is, how do I prove different types of special parallelograms on a coordinate plane? So we're going to start off with some definitions. Our first definition is parallelogram. Remember, parallelogram has to be a quadrilateral, and both sets of opposite sides are parallel. For a rhombus, it's a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. And then a square is a parallelogram with both 4 congruent sides and 4 right angles. Okay. So the next thing I want to know is how I can prove the things that we just discussed on the previous page. So here is a chart. It has 3 different things that I can prove. I can prove parallel sides, congruent sides, and right angles. So if I'm proving parallel sides, I need to find the slope of all of my sides because I need to prove my sides are parallel. If they are parallel, they will have the same slope. And then I just need to say which lines are parallel. So like line AB is parallel to line CD, and then my reason would be definition of parallel lines. For congruent sides, I need to find the distance of all the side lengths. So I can use the distance formula, or I can use the Pythagorean theorem to find the length of a side that is slanted, if it's vertical or horizontal, so right on the grid line, straight up and down, or straight across, I can count. And then if the 2 lengths of the lines are the same, I can say they are congruent. When I write it in my proof, so let's say line AB is congruent to line CD, then I would say my reason is because of definition of congruent. To prove right angles, I need to find the slope of all of my sides. And then remember, if it has a negative reciprocal, so an opposite sign, so one is positive, one is negative, and if they're fractions, the fraction numbers are flipped, so the tops and bottoms switch. Or if it's a whole number like 3, the reciprocal would be 1/3. And from there, I would need to say which lines are perpendicular. So, for example, line AB is perpendicular to line BC. My reason would be definition of perpendicular lines. Once I say that, then I can say what my right angles are. So using that same example I just used, my right angle would be angle B by definition of perpendicular. Okay. So we are given this polygon. It gives us the coordinate points, and then it's also graphed for us here. We need to decide if this is a parallelogram, and we're going to do it with a proof. So we're going to start off with our statements and our reasons. The first thing when I'm given a shape and I'm asked to prove what kind of shape it is, I want to start off by finding all my slopes. So I'm going to find my slope of AB, and then I'm going to find my slope of BC and AD. Let me get my screen pen out. So if I look at my slope of AB, I go up 1 over 2. DC does the same thing. So my slope for AB and DC is 1 over 2. And then let's look again at DA. So I go up 4 over 2. So my slope would be 2. And then I do the same thing for CB. It goes up 4 over 2, so it's also 2. So let me erase this. So I can say my slope of AB and CD are the same, and that's 1/2. My slope of BC and AD are the same. It is not 1/2. I don't know why this part isn't here. It is just 2. Okay. Then the next thing I can do is, because I have 2 sets of lines that have the same slope, is I can say those sets are congruent. So I can say, I'm not congruent, parallel. So I can say AB is parallel to CD and BC is parallel to AD. The reason for this is it's my definition of parallel lines. And then I finally need to answer my question on whether it is or isn't a parallelogram. I have 2 sets of parallel, so I have said this parallel is triangles. I have said those 2 sets are, or those 2 sides are parallel. and these two sides are parallel. So now that I have two sets of parallel lines, I can say ABCD is a parallelogram, and my reason is definition of a parallelogram. Okay. This one is similar idea, except I need to prove it's a rhombus. So when I'm proving a rhombus, I need to prove all four side lengths are the same. Okay. So I'm going to start off with my statements and reasons. Same thing that I started off with on my last proof is I want to go ahead and find my slope. So from A to B, it's 1/3. From D to C, it's also 1/3. From A to D, it's negative 1/3. And from B to C, it's negative 1/3 as well. So I will erase this part. I'll leave the four same sides because that's what we're looking for, so I want to keep that in mind. Erase, erase. Okay, so I have my slope of AB and CD are 1/3, and my slope of BC and AD are negative 1/3. I did not erase that negative. The reason for this is my slope formula. Then I can say this line is parallel to this line, and AD is parallel to BC by definition of parallel lines. Now that I have two sets of parallel lines, I can say it's a parallelogram. This is by definition a parallelogram. Notice, this proof is not asking me to prove it's a parallelogram. It's asking me to prove it's a rhombus. So I need to go a step further and say my shape is a parallelogram. I mean, not a parallelogram, a rhombus. So what I want to do is I want to go find all my side lengths. So remember when I drew my slope triangles, all of them had a side length of, I'll just do this one, had a side length of 3 and 1. So I need to find this missing C. Let me actually write C in a different color. Blue. Why did I write 3? I was writing C. Okay. So then I want to plug into the Pythagorean theorem, or I could use the distance formula. If I'm using the distance formula, I want to pay attention to my coordinate point at D, which is negative 1, 1, and my coordinate point at C, which is 2, 2. And then I'd plug those in for x1, y1, x2, y2. But because I can draw the triangle out, I personally am going to use the Pythagorean theorem. So I'm going to use 3 as my A, so I'm going to have 3 squared, and then 1 is my B, and equals C squared. 3 squared is 9. 9 plus 1 equals C squared. And then, sorry, this is kind of in the corner, I'm going to have 10 equals C squared. And then I want to take the square root of both 10 and C, which is 3.2. So I can repeat this for the other four sides, and it'll all give me 3.2 for this shape. So I can say AB equals BC equals CD equals AD equals 3.2. Anytime I find a side length, my reason is always distance formula. Then now that so I'm going to go ahead and mark up, I have 4 congruent sides on my shape. That's exactly what I was looking for in a rhombus. So I can say ABCD, nope, just kidding. I can say they're congruent now that I know they're the same length. And then I can say ABCD is a rhombus by definition of rhombus. Yep. Next thing I want to do is I want to prove if this shape is a rectangle. So rectangle needs 2 parallel lines. Four right, that is a terrible 4, angles. Okay, so first thing I need to do, statements and reasons. Okay, and then I want to go ahead. I have to prove it's a parallelogram before I can prove anything else. So I need to find my slopes. I'm going to go from here. It goes down 2 over 3. This one also goes down 2 over 3. From D to A, it goes up 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So it goes up 6 over 4. From C to, ooh, that was terrible. C to B, It also goes up 1, 2, 3, 4, 5, 6 over 4. So then for DC was negative 2/3. And for CB and AD is going to be 6 over 4, which equals 3/2. Sorry, my handwriting is a little messy. So I can say my slope of AB and CD are negative 2/3, and my slope of BC, oops, I did not want to give you that one. Slope of BC and AD are 3/2. So I will clean up my picture. Okay, so now that I know I have two sets of lines with the same slope, I can say I have parallel lines. AB is parallel to CD, and BC, sorry, it is very hard to write on a computer screen, is parallel to AD. Okay, so I've proven it's a parallelogram. Now I need to go prove it has 4 right angles. So I can say ABCD is a parallelogram by definition of a parallelogram. Then, because I know my slopes, so I had over here, I had those two slopes. They are opposite signs, opposite fractions. The numbers on the top and bottom are switched. So I can say any of those lines are perpendicular. So I can say AB is perpendicular to BC, AB is perpendicular to AD. So let me go mark these as I say them. AD, BC. Then I have CD is perpendicular to BC, and CD is perpendicular to AD by definition of perpendicular. And I went through and I drew those boxes that mean perpendicular. They also mean that they are right angles. So now I can write angle A, angle B, angle C, and angle D are all right angles. This is by of perpendicular. And so when you say something is perpendicular, it means it's a right angle. Now I have my parallel sides and I have my right angles. I can say ABCD is a rectangle. Okay, and in case you were wondering, we have one more slide. Okay, this one needs me to prove it's a square, so kind of like the the last shape was a rectangle. I need parallel lines, 4 right angles, 4 congruent sides. Okay, so start off with my statements and reasons. I need to, just like every other proof I've done, I need to go find my slope. So this one is up 1, 2, 3, 4 over 2, which would make it 4 over 2 is 2. This one is also up 4 over 2. From A to B is down 2 over 4. And from D to C is down 2 over 4. So that slope would be negative 2 over 4, which simplifies to negative 1/2. So I can say AB and CD have the slope of negative 1/2, and BC and AD have the slope of positive 2. Let's go erase my pictures. I mean, not pictures, writing. So I can see my picture. Okay. Then, just like before, now that I have all my slopes, I can say AB is parallel to CD and BC is parallel to AD. From there, so I have AB right there, right there. So now I can say ABCD is a parallelogram. That is not what I wanted to prove, so I cannot stop here. I do know my slopes are opposite reciprocals. Notice if I write them like this, negative 1/2 and 2 over 1, opposite fractions, opposite signs. So I can say AB is perpendicular to BC, AB is perpendicular to AD, CD is perpendicular to BC, CD is perpendicular to AD, and my reason is perpendicular lines. So I'm going to go draw on my shape to prove this, or not prove this, remember this. Those squares in the corner, yes, those are squares, are there to show me that they're right angles. So now I can say angle A, angle B, angle C, and angle D are all right angles. I know I fixed this before I started the PowerPoint. Definition of, not odd. Perpendicular. So then what I need to do next, so I have the parallel lines, the 4 right angles, I need to go for my 4 congruent sides. So remember, when I did my slope triangles, all of them had 2 and 4 as side lengths. So this is going to be my A, B, and I'm solving for C. Let's do this in red. There's really no good spot because I write too big. So I'm going to have 2 squared plus 4 squared equals C squared. 2 squared is 4. 4 squared is 16 equals C squared. Then 4 plus 16 is 20. That is a 2 in case you were wondering. 20. That looks even worse. Let me go erase that. 20. Okay. Now I need to get rid of my squared, so I take the square root. Square root of 20 is 4.5 equals C. So then I made a mistake here right here. Instead of 3.2, that should be 4.5. So all my side lengths are the same, and it's by the distance formula. Now that I know all my side lengths are the same, I can say they're all congruent. And then finally, I need to say what the shape is. It has parallel lines, it has 4 right angles, 4 congruent sides. That makes this a square by definition of square.